Hello, and welcome to Griffin's first installment in our data processing tutorial series. Today, we'll be processing data from the Specim AFX10 VNIR Hyperspectral sensor using the Griffin Processing Tool, or GPT for short. Before processing Specim AFX10 or any sensor data in GPT, we have to bundle our raw sensor data. Data bundling copies all raw sensor data into a clean and consistent folder structure and injects any necessary metadata required to process. To begin bundling, we'll choose the Bundle Data tab, then Create New Bundle. Here, we'll input the system's boresight calibration file, optionally, a processing extent file, and then we'll select our raw data source. In this instance, we'll use single source bundling because all our raw data exists in the same folder. If multiple flights of data need to be orthorectified together, we could add those additional missions here with the Add Mission button. Next, we have some optional parameters: pilot, location, and weather conditions or general notes fields. We'll skip this for now. Finally, we'll name our bundle and set the directory where we want the bundle saved. Press Create Bundle to begin bundling. After our data has finished bundling, we can view our GRAW bundle by pressing the Open Data Bundle button. Here, we'll see all the available raw sensor data split into proper subfolders with relevant metadata and log files created. To begin processing data, we'll return to GPT and select the New Job tab. In this tab, we will specify the processing configuration for our JRAW bundle through the use of a pipeline. We can store various pipelines on this page to use with different payloads or to generate different sets of products with varying parameters and resolutions. For this demonstration, we will create a new GNSS and VNIR pipeline. We'll select New Pipeline, New Task, and create a new GNSS and VNIR task. GNSS configuration is simple. Choose the networking mode and datum. SmartBase, which is selected now, will create a virtual network station at our survey location based on a network of publicly available core stations nearby. Next, let's set up our VNIR task. To generate VNIR products, an elevation model is required. Typically, we'll use an onboard LiDAR sensor to create a DSM. In this instance, we do not have a LiDAR sensor on our payload, so we can use a DSM from another flight at this location. Alternatively, for very flat locations, we can use the fixed value above ellipsoid option as our surface model. Let's select our LiDAR DSM. The rest of our processing parameters for our VNIR task can be left at their default values. Next, we'll specify our products to produce. Select New Product, and then select the default product. Here, we can view the different types of products available to us. For this dataset, we'll generate a spectral orthomosaic. We can rename our product and specify a resolution. Today, we'll use the new GSD-based resolution to allow GPT to calculate the maximum resolution possible from the dataset and generate products based on a percentage of that ground sampling distance. By default, this will generate products at 100% of the maximum resolution. Finally, we can name and save our pipeline. To start a processing job, we'll select the pipeline we just created and select our GRAW bundle. To process the GNSS data from this survey, we need to select the first and last GNSS files from our GNSS task. For our VNIR data, GPT will automatically convert our raw data to radiance. To convert that radiance data to reflectance, we must perform spectral target selections so GPT can employ an empirical line method for that conversion. Let's select our spectral target DHR files. Then we'll find the data cube with the targets visible, click Draw Target Bounds, and we'll measure each target. After we've measured each of the 3 reflectance panels, we can save our measurements and submit the job. At this point, the data will process and will return when it's complete. Our processing is now complete. We can see in the log at the bottom that this job took 25 minutes. We can then click the button above the job log to view our GPro folder and view our data products. We hope you found our Specim AFX10 processing demonstration helpful. If you have any questions or would like to learn more, please visit our website or reach out to our team. We're always here to help.